Alright, today we're focusing on a third type of bonding, which is metallic bonds. And our learning objectives for the day are being able to describe the electron C model of metallic bonds and explain how the bonding of metals and alloys affects their properties. So, we can describe metallic bonding using the sea of electrons model. Here, I have a piece of gold metal. And if we look at it at the atomic level, we can see that I have core, electrons and nucleus in the dark blue and the orange. And then this light blue represents the valence shells. And you can see that the valence shells of each of these metals, metallic atoms, overlap. So, like an ionic compound, the metal atoms become cations. However, in our metal-to-metal bonds, the metal atoms share their valence electrons among all the metal ions in a metal structure. This is why it's called the sea of electrons model, because our valence electrons can travel throughout the metal without disruption. So, we can define it this way, as metallic bonds are positively charged metal ions that are attracted to negatively charged electrons that flow throughout the material. This sea of electrons model is why metals have certain properties. So, before being hammered, the sea of electrons surrounds the gold cations, and if we can imagine this piece getting struck by a hammer, you can see that our gold cations move when the gold is hammered, but the metallic bonds are not broken because the sea of electrons moves with the gold cations. They can move in all directions, and so it's able to easily shift without breaking apart. So this gives way to a lot of properties of metals. This is why they can conduct electricity, why they are malleable, which we demonstrated in the last PowerPoint slide, and why they have a high melting point. But this high melting point is different depending on the metal. So here I have a diagram of sodium metal and a diagram of magnesium metal. And as we know, sodium has one valence electron, whereas magnesium metal has two valence electrons. So in sodium, our electrostatic attraction between our sodium ions and the sea of electrons is strong, and each ion contributes one electron to the cloud. But sodium has a melting point around 100 degrees Celsius. However, the melting point of magnesium and the boiling points of magnesium are higher than those in sodium because our attraction, the electrostatic attraction between our +2 magnesium cations and all the electrons in the sea of electrons is much stronger than it is in sodium. This is because magnesium ions have a 2+ charge, and each ion contributes 2 electrons to the electron crowd. As you have more valence electrons, and we'll see that transition metals can be very picky with how many valence electrons they have, the higher the melting and boiling points will be. So what I want you to do before you start the practice is I want you to return to our original question. Why do gems have different properties than metals? I want you to write your answer to the above question with the knowledge we've gained in this unit on ionic, covalent, and metallic bonds using our terminology that we have developed over this unit. After that, go ahead and complete the practice that I set out for you that will focus on reviewing Lewis dot structures and kind of classifying different compounds. Have fun!